Hello students and welcome to our video lesson. Today we are going to continue with Unit 3. Our learning target today is I can calculate missing angles using angle relationships that occur with parallel lines and transversals. So you're going to want to take some notes along with this lesson. I will point out when it is a good time to write it down. Okay, so we're going to just start with some practice. You do not need to write this down because we have done it before, but it's a good start to the lesson. So it says, which of the following names the relationship between angles 1 and 4? So what I did ahead of time is I circled these angles, and these are my options. So if we can go through it, I noticed that they're not interiors, they're not corresponding. Could they be verticals? Yeah, they're vertical angles. So that's one of our old angle relationships. So that is the answer. All right, let's try another example. So 1 and 8. What are these guys called? So if you remember in class, we talked about this sort of being a box in here. So 3, 4, 5, and 6 would be interiors. So that means 1 and 8 would be exteriors. And the only one we have with exteriors is alternate exteriors. All right, let's do it again. 3 and 5. So I labeled them right here. These are my interiors. That's what I see right away. They're inside my box. The different kinds of interiors, you can have alternate interiors or you can have consecutive interiors. These would be consecutive because alternate would be like 3 and 6 or 4 and 5. They are on the same side of this transversal M. So they are called consecutive interiors. All right. 2 more examples. 2 and 6 are right here. This is the weird one. If you think about that box again, 2 would be an exterior, 6 would be an interior. So the only one that applies to that is what's called corresponding. Correspondings are the ones, again, where you have something in the same location. So 2 is like the upper right-hand corner of these 4, and 6 is the upper right-hand corner of these 4. So they're in the same location in relationship to their lines. All right, last one, 4 and 5. 4 and 5 are both inside the two lines, so they're interiors, and they are alternate from each other because they are not on the same side of the transversal. Hence, they are alternate interior angles. All right, so that was a good review. Specifically, we're going to be doing parallel lines. I know this is a really weird symbol. I think something got screwed up with that, but these are supposed to be parallel lines, okay? So what we learned yesterday in our investigation is that parallel lines create a bunch of congruent angles. So what they want us to do in this example is to find the degree measure of all of the angles. So if you need to pause the video, this would be a good one to write down in your notes. We have a couple examples, but if you write down one of them, that should be good. Okay, so you should have unpaused the video by now. Hopefully your picture looks something like this. We need to find all the angles. So first off, I see this 75, and the first thing I think is number 3 is a vertical angle, which means it's the same size. It's also 75 degrees. And then I can figure out 1 and 4. I know they're going to be the same because they're verticals, and what I see is a linear pair. So like 4 and 75 are a linear pair, or 1 and 75 are a linear pair. So what I'm going to do is take 180 minus 75, since a line makes 180, and that's where I got this 105 off to the side. So 105, 105. Make sense? All right, and then the beauty of these parallel line examples is these 4 are exactly the same as these 4. And I simply know it because, say, 75 and 6 would be called corresponding angles. So they correspond to one another, and they have the same measurement when the lines are parallel. So 5 and 1 are going to be the same, 3 and 7 are the same, and 4 and 8 are the same. So you can literally take this pot of 4 and replicate it down here. So again, make sure you have this written in your notes. It's a great example, and we will do another one. Okay, here's another one. It says this time angle 2 is 45 degrees. I'm just going to put that there so I can see it. Again, you might not need to write this one down if the last example made sense, so let's just do it together. Find the degree measure of the rest of the angles. So one thing that I actually do a little bit differently than my last example is find all of the 45s first. I know 4 of the 8 are 45, and the other 4 are going to be the supplement of 45. So 3 is vertical to 2, so those are the same. and then they're exactly the same over here. I also sometimes just look at the picture, and if the lines are parallel, there's only two possible answers. So all the ones that are, say, acute are going to be the same size. Okay, you can just reason through this. So 6 is definitely less than 90, so that's going to be a 45. And 7 is also acute, so it's also going to be 45. So I have 4 of them the same. The other 4 will all be identical as well. And all it is I'm going to go 180 minus 45. That's how I got this 135 off to the side. And those are all going to be dragged into the same location. Again, notice this set of 4 is identical to this set of 4. I could just copy and paste and they would be the same. All right, we actually only have one more example. It's a pretty short lesson today. So I do want you to try this problem on your own. I know it's a kind of a beast to copy in. So at least pause the video for maybe 2 minutes and see if you can at least guess what most of these are. You don't have to necessarily write it down, but I would like to know if you can find some of these. So remember, the 2 arrows mean these 2 lines are parallel, and these guys both have 1 arrow on it, so that means they're parallel to one another. So I can guarantee you there's going to be a ton of 28s on the picture. Okay? So actually what I might do is I might do the 28s first. Can I find all the other 28s? Well, oh, I'm sorry, you should have paused the video, but now you're starting, okay? So B is going to be 28, right? Okay. B and C are going to be the same because their relationship would be alternate interiors if you just look at this set right here. Right? These are the parallel lines. I'm ignoring everything else. You can't see it, but I'm covering everything else up with my hands right now. So B and C are alternate interiors, so C is also 28. Okay, so now let's look at this setup here. So look at the parallels with 1 arrow. If I ignore this whole bottom line down here and this whole section off to the right, C and E would be considered corresponding, so that's also 28. All right, I think that's good for now. All those other angles within this kind of like rhombus diamond shape in the middle here, those are all going to be supplementary to 28, meaning we're going to go 180 minus 28 to find them. So A makes a linear pair, so that's going to be 180 minus 28, which is 152. A and D would be alternate interiors from one another, so that is also 152. There we go. Let's see, D and F are corresponding to one another, so those are going to be 152. And then if I'm just trying to use something different, you could look at A and G from back up here. A and G, focusing on this set with my cursor here, are alternate exteriors, so those are the same, so 152. Whew, okay, I think I got all those ones. Now let's attack this beast over here. Okay, I can do H right away. H and 62 make a linear pair. So we can go 180 minus 62 to get 118 for H. I and 62 are vertical angles. So that one's 62. K I can find by those are corresponding, the 62 and the K up here. And then these little marks, good reminder, right? Means they're congruent. Oh, but I don't need this one actually. But this angle, if I cared, is in fact 62. And then J, pretty obviously, is a right angle, so it's 90. So the reasoning I went through this does not have to be the same as yours, but hopefully that gave you a little preview and practice some more vocab. So that is the end of our video lesson, so feel free to start your practice problem, students.